Today I'll be looking at lesson 13, from ratio tables to equations using the value of a ratio. Let's look at exercise 1. Jorge is mixing a special shade of orange paint. He mixed 1 gallon of red paint with 3 gallons of yellow paint. Based on this ratio, which of the following statements is true? Let's go down one by one and check each one. First, 3/4 of a 4-gallon mix would be yellow paint. Well, let's think about in a 4-gallon mix, how many red would there be and how many yellow would there be? Well, we know that 1 gallon of red goes to 3 gallons of yellow. So if we keep that ratio of 1 gallon of red and 3 gallons of yellow, how many total gallons would that be? Well, that would give us 4 total. Well, if you know that there's 4 total, how many of those 4 will be yellow? 3 out of the 4. And when we have 3 out of 4, another way of saying that is 3/4. So it is 3/4. So this one is true. Let's put a T there. Time to look at the second one. Every 1 gallon of yellow paint requires 1/3 of a gallon of red paint. Well, here our original ratio has 3 gallons of yellow paint. Well, if we're going to turn 3 gallons to 1 gallon, we need to create an equivalent ratio with smaller values. So we got to turn 3 into 1. Well, how do you turn 3 into 1? You divide by 3. So if we're going to divide by 3, if we do that to one side, the yellow paint, we need to do that to the other side, the red paint. So we would do 1 divided by 3. I could write with a fraction bar, and 1 divided by 3 is 1/3, which again gives us 1/3 of a gallon of red paint, which is what it says in the statement. So this statement is also true. So let's put a T there. Time for the third statement. Every 1 gallon of red paint requires 3 gallons of yellow paint. Well, if we go back to our original ratio, he mixed 1 gallon of red to 3 gallons of yellow, so it's the exact same ratio in this statement as it is in this. So again, the statement is true. Let's look at statement 4. If there is 1 gallon of red paint and a 4-gallon mix of orange paint. Well, we look back at our original ratio of 1 to 3. 1 gallon of red and 3 of yellow gives us a total of 4, as we discussed before. So in this total of 4, there's 1 red gallon. So therefore, 1 gallon of red paint and a mix of 4 gallons of orange is true. Let's look at our last one. There are 2 gallons of yellow paint and an 8-gallon mix of orange paint. Well, let's think about this. If we need 8 gallons of orange, our original ratio of 1 to 3 gets us 4. So we need to double our original ratio, or double our recipe, basically. So if we double our original ratio and we double our recipe, that's going to give us 2 gallons of red paint and 6 gallons of yellow paint. Therefore, to get an 8-gallon mix, you would need 6 gallons of yellow, not 2. So therefore, this is false or not true. In exercise 2, we're going to be filling out a table. Based on the information of red and yellow paint given in exercise 1, complete the table below. Now remember, the information given to us is 1 red to every 3 yellow. And that gets us 4 total. Okay, so let's start with our first row of our table. It's missing the red paint, but it's giving us 3 yellow paints. So therefore, if we have 3 yellow paints, we need how many reds? Well, 3 yellow paints goes with 1 red paint. Okay, so this last column is talking about the relationship. This relationship is talking about how we're looking at our yellow paints. And our original value of 3 yellows, we multiplied by 1 to get our current value of 3. So let's look at our second row. Here we have 2 gallons of red paint. Well, how did we get the 2 gallons of red paint? Well, we doubled our 1 gallon of red paint. Since we doubled that, we need to double this. 3 doubled would get us 6. So what did we do? we did 2 times the original value of 3, and that got us our 6. Okay, so we got our second row done. Now we're going to our third row. The third row, this time we're missing the red, but we got our value of 9 yellow paint. So how did we get from our original value of 3 to our new value of 9? Well, we times it by 3. So if we did that side by 3, we got to do this side by 3 to get an equivalent ratio. 1 times 3 is 3. And that gives us our relationship of 3, our original value, times 3 to get our 9. Let's look at the next row. Here we have 12 yellow paints. Well, how did we get from our value of 3 to 12? Well, we multiplied by 4. So if we multiply by 4 here, we're going to have to multiply by 4 here to keep it equivalent. 1 times 4 is 4. And now remember, to get our relationship, how did we get from 3 to 12? Well, we did 3 times 4, which got us our 12. Let's look at our last column, or last row. We got from 1 to 5. Well, how did we get from 1 to 5? We multiplied by 5. So 3 times 5 is 15. If we have 15 there, then how do we get our 15? Well, to get 15, we did our 3 times the 5. And there we go. We have filled out our table showing 5 different equivalent ratios, all with their original ratio in mind of 1 red paint and 3 yellow paints. In exercise 3, we're going to be making a similar table, this time with purple paint. With this purple paint, we're going to be mixing 4 gallons of red to 1 gallon of blue. So that's going to give us 5 total gallons. So our first row, well, let's keep our blue. How much blue do we have? We have 1 gallon of blue. And then how many gallons of red do we have? We have 4 gallons of red. So our relationship, well, we have 4 gallons of red. And how do we get that? We did our 4 times 1. So there's our first row in our table. So next, let's double it. Let's take our ratios and let's double them. So the blue would become 2 and our red would become 8. So therefore our 8 we got from doing 4 times 2. Let's do the same thing with the next row. This time let's do it by 3. So 1 times 3 is 3. 4 times 3 is 12. So how many gallons, how did we get our 12? To get 12, we did our 4 times 3. Well, next, let's do it by 4. 1 times 4 is 4. 4 times 4 is 16. How did we get our 16? To get our 16, we did 4, original 4, and we multiplied it by 4, because we're quadrupling our recipe. Last one, let's multiply by 5. 1 times 5 is 5. 4 times 5 is 20. So to get our 20, we did 4 times 5. There we go. We have our table filled out. So you can see how our batches grew each time. Okay, well, let's use our table to help us calculate some questions about the paint. What happens if we had 24 gallons of red paint? How many gallons of blue paint would we need? Well, how would we get from 4 to 24? Well, to get from 4 to 24, you would have multiplied by 6. So you would have done 4 times 6. Well, if you did 4 times 6, let's do the 1 times 6. So how much blue would we need? We would need 6 gallons of blue. Well, what happens if we had 24 gallons of blue paint? Then how many gallons of red paint would we need? Well, how did we get from 1 to 24? We multiplied by 24. So we have to do the same here. We have to do 4 times 24 this time. And 4 times 24 is going to get you 96 gallons of red paint. If you would have 24 blues, that's a B, blues, and 96 red. It's quite a bit of paint. So there you can see how we used the relationship to help us figure out how much we would need for each of those values. Well, now that we've seen this ratio, the relationship in this ratio written out in numbers, and we figured it out here, let's see if we can put it in a little more abstract term or an equation. So let's think about a relationship between blues and reds. What do I always need to do to my number of blues to get my reds? Well, here in this time I did 1 times 4 got me 4. 2 times 4 got me 8. 3 times 4 got me 12. 4 times 4 got me 16. 5 times 4 got me 20. So whatever my blue was, I multiplied by 4 to get my reds. So let's use B for blue and R for red. So my B's, whatever I did, I multiplied it by 4, and that always equaled my reds. And we could think about the other way, and we could say, hey, however many reds I had, I could divide it by 4 to get my blues. So I could go from 4 divided by 4 is 1, 8 divided by 4 is 2, 12 divided by 4 is 3, 16 divided by 4 is 4. So for any value of red or blue, you can figure out the other one by either multiplying by 4 if you're given a blue, or dividing by 4 if you're given a red. With the relationship we just learned about the blues and reds with the purple paint, we're going to be looking at the blues, the reds, and the total paint. So looking at our instructions, using the same relationship of red and blue from above, create a table that models the relationship of these three colors, blue, red, and purple, purple being the total paint. Let B represent the number of gallons of blue paint, let R represent the number of gallons of red paint, and T represent the total number of gallons of purple paint. Then write an equation that models the relationship between blue and the total paint in the question, to answer the questions. So again, let's start. We had how many gallons of blue? 1. Our original ratio to 4 red. Well, how many total gallons would that give us? That would give us 5 total gallons. Okay, well, let's look at the second. Let's double it. 2 and 8, which is going to give us 10 total gallons. Multiply it by 3. This is going to give us 3 and 12, which is going to give us 15 total gallons. And then 4 and 16, multiplying by 4 to get 20 total gallons. And then we can go 5 and 20 to get us 25. So here we multiplied by 2, here we multiplied by 3, here we multiplied by 4, here we multiplied by 5. So now let's look at our equation. To get our total paint, what do we need to do to the blues? Well, let's look for a relationship here. So how if we went from 1 to 5, how I do that? Well, I can multiply by 5. Let's see if it continues. 2 times 5 is 10. 3 times 5 is 15. 4 times 5 is 20. 5 times 5 is 25. So you can see that whatever our blue paint was, we multiply it by 5 to get the total. So 5 times the B equals 5 times the blue equals the total paint, or the total purple paint. So what is the value of the ratio of the total paint to the blue paint? Well, the total paint was 5 and the blue paint was 1, so the value would be 5 over 1. How is this value related to the equation? Well, you can see that our 5 came from the 5 blues, and how many total is there? Well, the total, there'd be a 1 there. We don't write it in the algebra because there's no number in front, because it's just 1 total would just be the same as the total. But there'd be a 1 there, so 1 total. So that's, you can see how this is related to our equation. Okay, let's look at these same ideas with a different situation this time. During a particular U.S. Air Force training exercise, the ratio of number of men to the number of women was 6 to 1. Use the ratio table provided below to create at least 2 equations that model the relationship between the number of men and women participating in this training exercise. So, the number of men to women is 6 to 1, so that means there's 6 men to every 1 woman. So let's start to fill out our table here. There's 1 woman, 6 men. Okay, so let's continue to fill out our table by just multiplying by 2, 3, 4, and 5. So this would become 2, this would become 12, 3, 18, 4, 24, 5, 30. Okay, that was the easy part that we've been doing quite a bit of. So now we need to come up with two equations relating the men and the women. So let's have one where we're going to start with the men and one where we start with the women. So how can we turn the men number into the women, or relate the men to the women? So if I need to turn 6 into 1 or 12 into 2, how would I do that? Well, I would divide by 6. So the men divided by 6 is going to get me the women. So whatever number of men I have, if I divide it by 6, that's how many women there would be. Well, let's look at it now from the women's side. How would I turn the women into the men number? So how would I turn the 1 into a 6, or the 2 into a 12, or the 3 into the 18? Well, I would multiply by 6. So 6 times the number of women is going to equal the number of men. So there we go. We have created two equations. So now let's answer our question below using one of those equations. If 200 women participated in the training exercise, use one of your equations to calculate the number of men. Well, which one do we want to use? Do we want to use the top one, where we have men divided by 6 equals women, or do we want to use the second one, where 6 times women equals men? We're going to pick the second one because we are given the number of women, so we want the one where we're working with the number of women. So our equation is 6W equals M, or 6 times the number of women equals the men. Well, the number of women we now know is 200, so we're going to do 6 times 200, replacing the W with the 200, since we know that information equals the number of men. So 6 times 200 is 1,200, equals the number of men. So there we go. We used our equation by plugging in the value given. The value here was 200. We plugged it in for the W, and so we did 6 times the 200, which got us 1,200 men. Okay, let's look at another situation with using this concept. Malia is on a road trip. During the first 5 minutes of Malia's trip, she sees 18 cars and 6 trucks. So there's the ratio we're going to be working with. Assuming this ratio of cars to trucks remains constant over the duration of the trip, complete the ratio table using the comparison and let T represent the total number of trucks and C represent the number of cars she sees. Okay, so this time, our ratio table, they started filling it in for us. So we need to do need to fill in the rest of these numbers. So we're given 18 cars to 6 trucks. Well, which of these levels or which of these rows do we know some of that information? Well, here, this middle one, we know the 18. So that means this trucks is going to be 6. We started there because that was the information given to us. So now we can work up and down from there. So how did I get from 6 to 3? Well, I cut it in half. I divided by 2. So I'm going to do the same to the 18. 18 divided by 2 is 9. So there we go. I've cut my 18 in half to get 9. So now I'm going to work here again on the next one. How did I get from 6 to 1? Well, 6 divided by 6 is 1. So 18 divided by 6 is 3. Okay, so I got those two filled in. Let's fill in the ones that are bigger now. How did I get from 6 to 12? Well, to get from 6 to 12, I doubled. So 18 doubled is 36. And our last one, how did I get from 18 to 60? That one's a little trickier. So what can we do instead? Instead of trying to figure out how to get 18 to 60, that's tough. Those are numbers that don't work too well together. We can pick any of the other ones because these are all equivalent ratios. So I'd like to pick the number 3 because I know that 3 can go into 6 or 3 can go into 60 easily. How many times does 3 go into 60? Well, 3 goes into 6 twice. So 3 goes into 60 20 times. So I multiplied 3 times 20. So I'm going to do 1 times 20, which gets me 20. So you can pick any number to get to the other one. So now that I have my ratio table filled in, what is the value of the ratio of the number of cars to the number of trucks? Well, the number of cars is 3. The number of trucks is 1. So the value is 3 over 1. Now notice I picked this ratio because this is the easiest one to work with because the numbers are the smallest. Write an equation that would model the relationship between cars and trucks. Okay, so how am I going to turn my cars into my number of trucks? Well, to get from cars to trucks, how do I get from 3 to 1? Well, I'm going to do cars divided by 3. Well, how could we do it if we did it the other way? From trucks to cars. Well, how do I turn my trucks into cars? Well, trucks is 1, cars is 3, so 1 times 3. So there's 3 times the number of cars. So 3 times trucks gives us the number of cars. So let's use one of these equations to help us figure out the last question. At the end of the trip, Malia had counted 1,254 trucks. How many cars did she see? Well, which equation do we want to pick? The cars divided by 3 is trucks, or the 3 times trucks equals cars? Well, we're given the number of trucks, so let's use the one that we're working with, trucks. So it's going to be 3 times the number of trucks equals cars. The number of trucks is 1,254, so 3 times 1,254 equals the number of cars. Give you a second to work that one out. And you're going to get 3,762 cars. Okay, let's look at one last example together. This time we're looking at running and walking. Kevin is training to run a half marathon. His training program recommends he runs 5 minutes and walk for 1 minute. Let R represent the number of minutes running and W represent the number of minutes walking. So let's start by filling out the table. You can see here, the first one they gave us 10 and 2 for the number of minutes running to the number of minutes walking. But we already know that the number of minutes walking, if it's 1, the number of minutes running is going to be 5 because that was given us to us in the word problem above. So we can fill in the 5. So now we can just continue to work on filling in the rest of the table. Here we have 20 minutes running. Well, if I turn 10 into 20, how did I do that? I doubled it. So 2 doubled is going to be 4. Well, now I have 8 minutes walking. Well, how can I get to 8? Well, I could do 4 to turn into 8 doubled. So 4 doubled is 8. So 20 doubled is 40. So now we got to work on filling out the 50. Well, now remember, to get to the 50, let's pick one that works easily. 40 you can't turn into 50 easily. 20 you can't. We could do 10. How do I turn 10 into 50? Multiply by 5. So 2 times 5 is going to be 10. So there we go. We have our table filled out. So now what is the value of the ratio? Well, again, our value of the ratio of minutes walking to the minutes running. So the minutes walking is 1, and the minutes running is 5. So our value is 1 to 1 over 5, or 1/5. So now it says the last part is write an equation you could use to calculate the minutes spent walking if you know the number of minutes running. Okay, so we know the running. So what can I do to the running to get to the walking? So I'm going to start with the running, or my R. So if I know the running, what can I do to that? So how am I going to turn 5 into 1 or 10 into 2? Well, I'm going to take my minutes running and I'm going to divide it by 5. So running divided by 5 gives me the number of minutes walking. So there we go. Running divided by 5 gets me the walking.